Good morning, class. We're going to be just briefly going over this deck. It's primarily just a collection of material on the internet that I'm highlighting about XP, JUnit, test-driven development, and behavior-driven development. And then we'll dive into some code. But first, just wanted to highlight a few things. This is pretty much like reading material for you, but I just wanted to point out. So with extreme programming, the material here just kind of points out some of the values. Extreme was popular in, I say, the late 80s, early 90s when it started. The main shift being that software was developed in such a strict structure and in a cultural way that was very compartmentalized and specialized. And so XP came along and tried to change that culture with a focus on back to simple design, communicating and sharing and being respectful to each other. So primarily a culture shift, but there was a lot of technical aspect as well. Some rules of extreme programming, user stories here. We talked about that in the past. CSC cards being used for design, spiking. When you're not clear on requirements, you kind of focus on and try to prototype or develop a solution so you can better understand how to approach that. Coding, as an agile practice, there's not a lot of documentation. So writing the code and having something working right away is actually more important. But in order to make sure you guide, if you don't have a lot of clear requirements, the unit test is used in place of the requirements. So the unit test is a way to specify what should be built. So we'll do some unit testing discussion today as well. So take a look at these diagrams. Just gives you the workflow of those practices in XP. And another good resource is on the Agile Alliance, the URLs shown here. The Agile Alliance Subway, which is basically a map of the main practices and of different agile methodologies and where they kind of overlap. We can see here we discuss Scrum. So if you look at Scrum, which is this color line right here, which is the red line. So we see some of the practices of Scrum. So you see the iterative development. This is one here. Time box, daily meetings, which is one that's shared with pair programming. The pink one is the extreme programming. So you can see that these practices are shared. Oops, not that one. With Scrum. So along here we have your daily Scrum, your burn down chart, task board, definition of done, estimation in points, planning poker, relative estimation, backlog, and backlog grooming. And so those are some of the practices of Scrum. This site also gives you a brief definition of these things, so it's good as review. But if you look at XP, it's the main line in the middle going across, and you can go ahead and go through the slide deck and take a look at some of these definitions. It's also available on the website. So I'll kind of breeze right through these because you don't want to spend time just looking at definitions. Unit testing. So like one of the key XP practice, in fact, the inventor of one of the inventors of XP also created JUnit, which is a testing framework for Java. And the idea is to specify the external behavior of a component. Here we talk about class, so that you can write code to exercise a test. So you basically write the test, and your code initially would break at first because it doesn't pass the test, it hasn't been written yet. And then you start writing the code so that it all start passing all the tests. And then, of course, also when you find bugs, you can add those to the test suite. Or as you develop, you also develop tests. So the testing itself is done in parallel with development, which is a shift from the practice prior to this, which was you do all your testing first. I'm sorry, you do all your development first, and then you test. You can't test until all development's done. So testing fundamentals, you want to know, again, the black box behavior and test for those that behavior. You look at also boundaries conditions, positive and negative tests, success scenarios, and alternate scenarios. Boundary tests could look at values, nulls, large numbers, empty collections, and so on. And having a test harness is some additional code that facilitates the testing. So, for example, if you have an end-to-end test, it's kind of hard to do the testing if you don't have a user. So you can write some class that sends requests into the UI, into a UI layer, acting like a user. So it acts out a scenario. So that's additional code around to facilitate testing. Stubs, mocks, and proxies. Also, when you first develop your program, you don't have the code yet, right? So you're writing the tests, but in order to make tests a system, you may have to, in order to have, you may have components or classes or objects that depend on other objects. So it's hard to test it without another object to interact with. Like in our first lab, you have the inspector and the pickers, so kind of hard to do any testing of inspector's behavior. I'm sorry, the picker's behavior if the inspector doesn't select it. So you might have to have a stub that initiates that request in order for you to test that interaction. So stubs, mocks, and proxy. A stub is looking primarily at input and outputs, exercising a specific value coming in or coming out of the stub, so it just returns some fixed value. A mock is kind of like a stub, but it does more. It tracks interactions within that a particular unit. Is exercising. So if there's some communication, some code, some interaction between objects, the mock could track that and make sure that the interaction exists in order to pass the test. And then a proxy is kind of like a mock, but it actually forwards the interaction to a real class, to a real object, and then performs the tracking part of the mock to validate the test. In unit testing frameworks, we look at junit. Here's an example of a junit test. So we have a test class, typically defined with the word test, and some test method, like this one's testing an add for a calculator. Before, in the older versions of junit, it was simply just the fact that you have the method with the name test was enough for the testing framework to recognize that method is a test method. But in newer versions of junit, you don't have to have that name necessarily. You need to put an annotation to mark that that's a test method. And of course, what you're going to be testing might be here. This is the object you're testing. you instantiate the calculator, and you want to, in order to pass a particular test, you're checking for some result. So that checking, there are a set of assert methods in the framework you can use, and you can use those. Assert, there's a list of them. You can look it up on the API guide. Here's some examples down here. You can basically assert that the actual result is the same as the expected. So when you add 10 and 50, you expect 60, and if what is returned is 60, then the test pass. Here's some more examples of the assert methods, and let's take a look at that. And then behavior-driven development is a evolved extension of unit testing. So with unit testing, you're looking at only the behavior of a component. A complete system is composed of many components. So from an external user point of view, the whole system has a certain behavior, and you may want to specify that external behavior and have it tested. So it's sort of like an end-to-end testing for your system or application. In the way, I think we talked about this briefly before, but the way that you specify this is really for user stories. This is an example of a user story. So for user stories, here's a slight variant of the user voice form, because you have the as a store owner, it's in the middle, so you know it doesn't really matter what order these are written in. But here we have a user story. It says, in order to keep track of the stock, as a store owner, I want to add items back to stock when they're returned. So the scenario would be like acceptance criteria, 2 of them. And it's written in the format for behavior-driven development. Given something, some condition, which is some event, some condition, and then on a certain event. So when something happens, with some starting condition, and when something happens, then the expected result should be this. So that's pretty much the format. So given some condition, meaning that the precondition or existing state might be the customer already bought a sweater, and I have some left in stock, and then an event happens. That event being that the customer wants to return it to get money back, refund, and then if they did that, then the expected outcome would be that the inventory now is at 4 instead of 3. Where is that? Instead of 3. Okay. There are some frameworks, Java-based framework that extends beyond JUnit, that actually allows you to write code like this, the structure to validate the behavior of the system. We won't get a chance to go into those frameworks in this class, but just to make sure that let you know that there are some out there. You can check out those 2 links on the bottom of the slide. Okay, so that's a really brief overview of XP JUnit behavior-driven development and test-driven design. Go ahead and go back over these slides. They will be posted. They're actually already posted on Canvas. Think of the slides as reading material. Now I'm gonna end this video, this recording, and the next one we'll go over some source code to get you